One of the questions I've heard a lot over the years about taking resistance readings on a multimeter is, what is a high reading, what's a low reading, what's good, what's bad? How do I tell the difference? So what I'm going to show you today is the relationship between resistance and voltage and how we can use our multimeter to see this relationship as we play around with a circuit. And what this is going to show us is how to use voltage readings to get better context on our resistance readings, and how voltage readings can help us find problems of resistance in a circuit. So what we're going to do here is we're going to start off with a very simple resistance reading on this little resistor I have here. Now this is a 1,000 ohm resistor. On my multimeter here I have K with the ohm symbol. That's kilo ohms, so this is reading in increments of 1,000 ohms. So I'm just going to take my probes, go to each side of this resistor, and you can see we're reading 0.992, so that would be 992 ohms, which is good. So what we're going to do now is we're going to go ahead and put voltage on this and then do a voltage reading. Now I have 24 volts coming off my transformer, going to one side of the resistor, coming off the other side and going back to common. I'm going to put my multimeter in the voltage reading, make sure I'm in the proper range, and then we're going to go ahead and take a voltage reading across this resistor, and we are reading 28.35 volts. Now if we go to our transformer and take a reading there, you can see we're reading exactly the same thing. So whatever voltage our transformer is putting out is traveling across this resistor, even with 1,000 ohms of resistance there. Now we're going to do the same thing with a contactor. So I'm going to go back to my ohm readings. I'm going to make sure I'm not in kilo ohms. So I'm just going to go to regular ohms. So you can see I'm in my regular ohm reading there. And when I take a resistance reading across this coil, you can see I'm reading about 12 ohms of resistance. Now let's go ahead and put power to it the same way we did to our resistor. So I got 24 volts coming out to one side of the coil, coming out the other side, back to common on the transformer. Turn the power on. You can see our contactor pulled in. We're going to go back to voltage, make sure we're in the proper range, and then take a voltage reading across the coil here. And you can see we're reading 27.5 volts. Now if we go off the transformer, we are also reading 27.5 volts. So what we see here is no matter what the resistance is, whether it's 1,000 ohms or 12 ohms, we're still getting the full voltage across these components that the transformer is putting out. Now let's see what happens when we put these two components together into a circuit that's wired in series. Now what I mean by a circuit that's wired in series is that each component in this circuit is wired one after the other. So the electricity has to flow through each component one at a time to complete the whole circuit. So we can see we have 24 volts coming off our transformer, one side of the coil, coming out the other side, going into our resistor, leaving the resistor, and coming back to common on the transformer. Now let's go ahead and turn our power on, and you can see our contactor didn't pull in. So if we were to take our multimeter, put it in voltage, and do a voltage reading across this coil, you could see we're only reading about half a volt there. Now if we did the same thing on the resistor, you can see we're reading 28 volts there. So right now we should be reading about 28.5 off of this transformer. And 28.35, pretty close. So what's happening here? Why is the contactor not pulling in? What we have here are 2 points of resistance in this circuit. Now that resistor is definitely the highest point of resistance, and what we're seeing here is the relationship that voltage has with different points of resistance in a circuit. So with the higher resistance, all the voltage is going to that point, and the component with the lower resistance is barely getting any voltage at all. So what's happening is that these two different points of resistance are causing our voltage to split. And the point of higher resistance is getting most of it. But when we add the two together, we're getting the full output of the transformer. Now what I have here is I removed the resistor and I put another contactor in that's identical to this one. So both of these contactors have about the same resistance reading, about 12 ohms. So let's go ahead and turn on our power, see what happens. Now you can hear they're chattering, all right? There's not enough voltage there to pull these contacts in. So let's take a voltage reading across the first coil, and you can see we're reading just over 13 volts there. Now if we do the same thing on the other coil, you can see we're also reading just over 13 volts there. So we should be reading about 26.5 volts off the transformer, and there we go. So what's going on here? Because both of these contactors have the same resistance value, what they're doing is they're splitting the voltage evenly to both contactors. So we got 13.5 here, 13.5 here, and neither one of those voltages are enough to pull in the contactor. Now I put another contactor in here, and this is a single pole contactor, and this contactor has a slightly higher resistance. This has 17 ohms to it. So let's go ahead and turn our power on and see what happens. Now, as you can see, our contactor with the higher resistance value actually worked. It pulled the contactor in. So let's go ahead and take a voltage test across our first contactor, and you can see we're only reading 4 volts there. If we go to the other coil and measure both sides, you can see we're reading just about 24. So 24 here, 4 here, that's about 28 volts total, which is what we should be reading off our transformer. And there we go, 27.9. So the different resistance values caused the voltage to split proportionally. The higher resistance got more voltage, lower resistance got lower voltage, and because this one got more voltage, it had just enough in there to pull the contactor closed, where this one at 4 volts did not. Now I'm going to show you a little something interesting here, and please don't do this when you're trying to diagnose a system, and I'll explain why in a minute. What I'm going to do is I'm going to take this magnetic jumper here, simple wire, there's no resistance on this, and what I'm going to do is I'm going to bypass the resistance on this second coil here, and watch what happens. You can see my other contactor pulled in, and this one I'm bypassing opened up. So what am I doing here? Now I'm going to take my multimeter, I'm going to do another test here, and you can see I'm getting 27.5 volts there. Now if I measure off the transformer, I'm also reading 27.5. And if I take my voltage reading across the coil that's bypassed, you see I'm reading almost no volts there. So what's going on? Basically, by giving the electricity a path of 0 resistance to travel, I essentially took that resistance out of the circuit that's off of this contactor here. So the only resistance on the circuit now is in this contactor, and all the voltage was able to travel to that point of resistance, providing enough voltage we needed to pull that contactor in. Now, if I were to take this jumper off here and go to the other one, you can see this one opened up and my contactor number 2 reclosed. And that is because I took the resistance of this coil out of the circuit by allowing the electricity a path of 0 resistance, and now all my voltage is over here. So when we take our resistance readings on these coils individually, we get 12 ohms, 17 ohms, 1000 ohms. That's not really telling us if there's a problem or not. What's really telling us whether there's a problem is the voltage drop across that component. Now, one thing you can do if you have a voltage drop across a coil is you can test the actual voltage coming into the coil to see what you have. And as you can see here, I have 28 volts coming into my first coil, even though it's not closing. But when I measure across the coil, I'm only reading 4 volts. So that's telling me I have another point of resistance in this circuit that is higher than the resistance of this coil, and that is absorbing most of the voltage in this circuit, not leaving me enough to operate this contactor. Now, you're obviously not going to see 2 contactors wired in series like this in the real world. I did this on purpose to prove a point. But there are natural things that can happen in a circuit that can mimic the same results we're getting by adding a second contactor in there. And this would be things like rusty terminals, loose wire connections, corroded and pitted contacts, and things of that nature. Now, once you've had the opportunity to test the resistance values of a couple of relays and a couple of contactors, you'll be able to identify when a resistance reading is really high on a component causing a voltage drop, or whether there is a voltage drop occurring because of resistance somewhere else in the circuit. Now, if you're reading 12 ohms or 17 ohms on a contactor, but you're seeing an 80% voltage drop across it, the odds are pretty good there's nothing wrong with that contactor, and you have resistance elsewhere in that circuit stealing voltage that's not allowing the contactor to work. So by taking resistance readings, getting familiar what's typical on those types of components you're testing, and taking voltage readings and being able to see whether or not you're having voltage drop across these components, using both of these things in your arsenal will allow you to get better and finely tuned into what kind of problems may actually be occurring in a system. Hope that helped you guys out. Thanks for watching.